All right, so we're looking at example problem number 5. And the first thing we're going to do is draw the lines, right? We're going to draw the straight, thick line, and then the dashed line right there at the plus. And now we're going to put our elements over on the left. And look, we've got another 2-element problem. This one should be fairly simple, right? So we're going to look at this, and we're going to see how to fill in the rest of this. So again, you can pause here and see if you fill yours out correctly. Phosphorus, there are 4 in this one. There are no oxygens. There are no phosphoruses there. There are 2 oxygens. There are 2 phosphoruses here and 5 oxygens there. Now, this is another one where we're going to go to that simple rule, right? Which of these is the simplest inequality for me to figure out? Is it 4 to 2 or 2 to 5? 2 to 5 is hurting my brain. I don't like to think about that, so we're going to worry about the 4 to 2 inequality first. So how do I make a 4 into a 2? Well, you can't. So you got to go the other way around. I got to turn this 2 into a 4, and you do that by multiplying it by 2. So if I put a 2 here, that'll multiply that one by 2 to give me 4 phosphoruses, but it'll also multiply this one by 2 to give me 10 oxygens. So now I need to worry about this inequality down here on the bottom, 2 to 10. And of course, how do you make a 2 into a 10? You multiply it by 5. That's it. Everything's good. This will now go to 10 oxygens. And now we've got 4 to 4, check. 10 to 10, check. Looks like a difficult problem, but once you break it down piece by piece, it's actually fairly simple. Now on to the last problem, the most difficult problem. If you can do this problem, it is you can balance any equation whatsoever, no problem whatsoever. This one right here, I can already tell you we're going to make a mistake, and we're going to have to correct that mistake while we're doing this one. But you know what? Sometimes you do that when you're balancing an equation. Sometimes you got to start back over from scratch. You've gotten yourself into the 30s and 40s on some of these, and you need to start over. And you know what? That's okay. And sometimes you get back up in the 30s and 40s again, and you're like, well, maybe it was supposed to be 30 or 40. There are 3 elements here. There's nitrogen, there's hydrogen, and there's oxygen. So we only have 3 elements, but believe it or not, this one's going to be really tough. It's because of that oxygen. You'll see it's going to be a tricky one. So nitrogen, there's 1 here. There's 3 hydrogens here. There ain't no oxygens there. Over here, there's no nitrogens, there's no hydrogens, but there are 2 oxygens right there. Over here, there's 1 nitrogen. There's no hydrogens. There's 1 oxygen. Here, there's no nitrogens. There's 2 hydrogens, and there's 1 oxygen. Whew. So when we're looking at this, it's 1 to 1 here. Check. It's 3 to 2 here. Uh-oh. And it's 2 to 2. There's 1 plus 1 on this side. So believe it or not, that one right now balances out. But this 3 and this 2, they do not balance out. So I've got to get 3 and 2 to be the same number. And I'm going to tell you, a lot of you might go to like trying to remember least common multiples from 5th grade. But you know, the cheater method here is we're going to multiply each by the other one. So in front of the 3, we're going to put a 2, right? Which is going to, again, don't forget, multiplies everything underneath it. So that becomes a 2. That becomes a 6. Before I deal with this problem, we're going to come over here and we're going to look at this. Remember, we wanted to turn this into a 6 now. So we're going to put a 3 in front of that. So that becomes a 6, and that becomes a 3. Okay? All right. So now we need to look at what inequality we had. Well, now we've got 2. We've got this one is 4, and this one is 2. Oh, that one seems really complicated. It's way easier for me to deal with this 2 to 1 business right here, right? So that's what I'm going to do. I'm going to deal with this simple problem first. 2 to 1. How do I make a 1 into a 2? Well, you multiply it by 2. So we're going to turn that into a 2, turn that into a 2. And now we look and see what we've got here. We've got, oh, fudge, there's a huge problem here. There's a 5 on this side. 2 plus 3 equals 5 for oxygen on this side. This oxygen is only a 2. Again, I go back to what I did before, right? When I had 2 on one side and 3 on the other side, we just multiply them by each other. So I'm going to take that 5, I'm going to multiply this oxygen by 5. That's going to give me that 5 right there. That means we're going to have 10 oxygens on this side. Now I'm going to multiply everything on this side by 2. So that goes from a 2 to a 4. That goes from a 3 to a 6. And now everything over here gets multiplied by 2. That becomes a 4. That becomes a 4. That becomes a 6. That becomes a 12. Oh my gosh. And that created a new set of problems, right? Our oxygen's fine. We have 10. We have 10 over here. 4 plus 6 is 10 on this side. That's no longer 2, right? We got 10 right there. We have 4 plus 6, which gives me 10 on this side. But, oh, man, we got a problem up here, right? This is 6 and this is 12. This is 4 and this is 4. Excuse me, this part's 4 and this part's 2. Oh, gosh, what are we going to do? Well, all we got to do is we got to change that to a 4, right? Multiply it by 2 to make that a 4, and make that one a 12. And the whole thing just comes out perfect and beautiful. Tough problem right there, really tough. Notice we had to come back and we had to kind of change ourselves a little bit. This is in the top 10% of problems, so most of them will never be this difficult. So hopefully you now have enough that you can go back and you can do some more problems on that worksheet.